While the wheel might not need reinventing, the rubber and steel that wrap around it have been fertile areas for improvement since the very first tires. Hi everybody, I'm Adam Savage, and today we are going to take a super deep dive into the world of modern tires.
Michelin is soon launching the X-Line Grip D,
A new line haul drive tire over 8 years in the making. And here's the thing, this tire is following up Michelin's XDN2, a product with a proven track record on the road. That is a daunting task. So Michelin has hired me to help explain the technologies they developed for the X-Line Grip D and why they are so confident in its performance gains. And to help me understand what it takes to reinvent the trucking tire, I visited Michelin's North American headquarters in South Carolina to learn from the designers who've spent the better part of a decade obsessing over every groove on this new tire.
Hello, Tyler.
Hi, Adam.
How you doing today?
I'm doing very well.
All right, tell me what this big, beautiful thing is here.
So this tire right here is the X-Line Grip D. It's part of an 8-year project that has come to fruition that we're ready to launch to market here coming in July.
Okay, now, is this a new tire that is adding to your product line, or is it replacing something?
So it's intended to replace 2 products. It's the XDN2, which is our best-in-class tire for wear and winter traction performance.
Okay.
And then some of it will replace the X-Line Energy D, which is one of our long-wearing energy drive offers.
How long have those been in production so far?
The XDN2 has a legacy of its own. It's been around since 2003.
Okay.
Our customers really love its traction, specifically winter traction performance.
Yeah.
And it's very hard to replace a 20-year benchmark that
was
has
my
such
question.
good traction.
Yeah. This tire is a real jump forward. I'm curious, what are the metrics of that jump?
Right, so the X-Line Grip D is going to provide 20% more miles versus the XDN2 with less tread depth.
With less tread depth. And you've used the same exact amount of rubber too.
Right, so with the X-Line Grip D, with the angled grooves, we're able to put the same amount of rubber volume as we have at the XDN2 with less tread depth because of the efficiency of the sculpture. And with a new tread compound, we're able to get this improvement of 20% in mileage versus the XDN2. Wow. And on top of that performance, right, we have this great end-of-life snow traction that we get.
Yeah.
And not only is this tire great in wear and traction, it's SmartWay certified. So it has a low rolling resistance threshold that allows it to go into all markets in the United States.
Okay, so 8 years ago, you start developing this thing.
Mm-hmm.
How do you prognostic? How do you think about a brand new tire when you have an existing tire that's great?
Yeah, so a lot of tire design, we talk about doing incremental change, 5%, 10% in wear, rolling resistance, traction. For this tire to replace the 20-year benchmark, right? Yeah. We really went back to the drawing board. We started with slick tires. Imagine like a racing slick, but a truck tire, right? There's no features on it at all, right? And we did some carving studies, right, to see what would happen if we changed the angle of our rain channels, right? If you look at a truck tire, a regular truck tire, they have these circumferential rain channels, right, to evacuate the water, right? So
the whole goal is that those channels push out the water while you're driving and keep it from getting underneath the tire.
Exactly, right? If there was no such thing as rain or snow, we could just run on racing slicks on trucks. Wouldn't that be fun? Yeah. So the idea was we went back to the drawing board. We did carving studies, right, to see what could we change with our dimensioning of the tread pattern to try and break this compromise of rolling resistance, wear, and traction.
So these are the things you have to balance when designing a tire, and I'm guessing you don't get all that you want out of all 3.
Right, it's always this trade-off, right? For everything you get in wear, you might lose in rolling resistance and traction, and vice versa. You get in traction, you lose it in rolling resistance and wear. So it's like you're balancing this 3-legged stool all the time in terms of design, right?
Yeah. So this idea of starting from scratch, that's not really a common design approach.
No, it's pretty new, and that's why the project has been 8 years, 8 years running, right? We started with carving, and then we did a mold, right? That was based off of our carving. We did many different iterations of different carving of different angles and things like that, and then we built a mold, and we saw what went well with that, and we threw out the things that weren't good, and we kept the things that were good and continued to iterate, right? You think about the design process, right? Early on, you're taking these big swings at making big changes, right? And And then as you get closer and closer to something that's like market ready, it's more of like you're using like tweezers, right, to do these fine tuning and little things. And you might see some nuanced differences from what we did in our development versus what actually makes it to market.
I think that most people don't realize when they look at a tire how intensely designed the entire topography is.
Right.
And I'm guessing after almost a decade on this, you understand the interstices of this deeply in your mind. Like this whole tire's in your head.
Yes. And I see it like anytime I see a truck out on the road that could potentially be one of our partner fleets that we've tested this with, I'm looking for the angled grooves. Like I want to see them. I want to see it out in the wild. And pretty soon we should see it everywhere out in the wild. And you're right. I go to sleep at night thinking about like, what are these different angles? How can we make them better in future generations of this? Now that we're going to launch this, what's the next generation going to look like?
Okay, so these angles, this is a fairly radical look. It looks quite different. I'm curious in the design process as you were iterating, was there a moment at which you were like, you got a test result where you're like, oh, this is the way, this is the direction?
Yeah, the thing that's been really surprising has been its traction in snow. It's really interesting, right? When you think about the tire it's replacing, the XDN2, it's got those longitudinal rain channels that I talked about, and they've got lots of sipes, so many sipes.
Sipes are the little offshoots that allow. These are sipes.
Yeah, the things that go across that look like little waffles.
Okay, now, and what do those? So obviously these are for moving water and other. But what do the sipes do?
So those provide biting edges, and that's specifically for our snow winter traction, right?
Oh,
the way I like to describe the XDN2, right? It's like a fine-tooth gear, right? Early in life, it's got so many sipes, and it will bite into the snow, and it will, really dig your way through. With this tire, right, we've taken out the amount of sipes, so we've increased the space a little bit, right? And we've added these angle grooves. So we have a fine-tooth gear that helps bite into the snow. And if you think about it, think about how this tire would roll through the contact patch.
Right, so it's rolling like this. When you say fine-tooth gear, you mean like these are meshing?
Yeah, like these are teeth of a gear biting into the snow, pulling your truck forward, right? So if you think about this, the angled grooves, right? They have this like projected edge that is constantly biting. So think about a fine-tooth gear and a lesser fine-tooth gear, right? A bigger pitch.
Yeah.
Together, working together, biting through the snow.
Oh, wow. Has the development of this changed the way the company's thinking about tires across the board?
I think so. And we're already starting to work on how can we take what we've learned from this tire and the angled grooves and what it does so well to break that compromise of traction, rolling resistance, and wear that I've talked about, and how can we apply it to other dimensions and other sizes and other zones even, right? In Europe and Asia and India, anywhere. We're trying to capitalize on what we've learned here and apply it elsewhere.
Okay, so I see all this wonderful topography, and it's a great idea, but there's the conception of it, and then there's the figuring out how to manufacture it. Am I right? Those are two very different problems?
Right. So we have our mold manufacturing process, right? So we have, these lamels that are sipes that are part of our manufacturing process. And you can imagine, you take a tire that's slick, it's uncured, and you push it into a mold, and it has to be ripped out of the mold, right? So
I don't even know.
There's a lot of force that goes in that.
Because we're holding this piece of low durometer urethane, but this is much, much harder.
It's very rigid, right? You need rigid rubber to have good wear performance in the field.
Over this process, how many different iterations are there of this pattern?
It's really ended up being about 6 to 7 iterations to the final product that you're seeing today.
How have you guys worked on the design of how this tire wears over its lifetime?
Right, so as this tire wears, as part of the tread efficiency that I've talked about, it maintains its traction performance as the tire loses its tread depth and wears through life.
Okay, so I have this impression that as a tire wears, it gets worse and worse and worse over its life until you have to replace it. But you're saying that it has a very consistent behavior over that lifetime.
That's right. Over the life of this tire, it maintains a high level of traction, even at low tread depths.
Did you work to design in the ability to retread these?
Yes, exactly, right? So this is on our new casing, which our DuraCore casing with Infinicoil and Power Coil. And it's designed for 1 million miles, and it gets retreaded multiple times.
Over that 1 million miles?
Over that 1 million miles. And typically, what you'll see in the life of a tire In a drive tire, right, you'll see it get its first life with its regular tread, and then it'll get retreaded and get put back on the drive axle for its second life, and then it will live out its subsequent lives on the trailer axle. In the steer tire, you'll see a little bit different, right? The first life will be on the steer tire, then they move it to the drive axle and then the trailer axle. So it's just like this little step down the tractor trailer. You start at the steer and work your way to the back, and it lives out its life on the trailer.
Now, we're talking about this purely in terms of right now the rubber out here, but you're talking about this as the DuraCore. That sounds like there are so many parts of this that other design teams are working on and refining and perfecting over the years.
Right. So if you think about a tire design process, I'd like to say it takes a small army, right? When you think about the casing and the sculpture itself, it's hundreds of people, from people working in the factories, people doing design for manufacturer, compounds, materials, testing even. It's an army of people that all together, it's this cross-functional team where we come together and are able to bring all of our ideas together, and we end up with a product like this.
But that many integrated teams and people working on all these different components that are interdependent, it's kind of amazing to me that Michelin was like, hey, let's go blue sky and invent something that's never been done before. That's got to be a real trust fall to a certain extent.
Yeah, well, it's the Michelin DNA, right? We've been innovating for hundreds of years, right? We've invented the radial tire. We continue to do new things in different fields, truck tires, passenger car tires, et cetera.
It sounds like, as a designer, this is a really amazing and unique opportunity to understand at a really deep level all of the innovation and what has gone before.
Right, for sure. And I like to think this is the beginning of a paradigm shift in the drive tire industry in North America and maybe even the world, right? No one has ever seen something like this before in trucking. We've seen it in passenger car. Think about the cross climate. It's very similar. But in the trucking world, this is new. This is something we've never seen before. And I wouldn't be surprised if there's a phase shift in the industry.
Tyler, you've run, I'm sure, countless simulations on this, but given that we're looking at a real tire, I'm guessing you're also doing some road simulations, yes?
We are.
Is it possible that I can see some of those?
You certainly can.
Tyler, thank you so much, man.
Thank you, Adam.
Okay, so I get how X-Line Grip D's angled chevron grooves work in principle, but all of this is in the realm of theory and simulations until the rubber meets the road. So my next stop is the test track at Michelin's Lawrence Proving Grounds to ride along with test drivers whose job it is to see if this new design really works.
This behind me is really cool. I'm at a Michelin facility, and it makes sense. Michelin's a big company. Big companies like to have, statues and branding on the facility. But that's not what this is. This is just one of their products. When Michelin says they make every kind of tire, they also make this, and this goes on a vehicle of a size I can barely imagine. But I like the feeling of being around something this big. It's like a reverse vertigo.
Hello, Derek.
Hey, Adam.
Dude, okay, let's start with where we are and what you do here.
Okay, so we are at Michelin's Lawrence Proving Grounds, the North American on-vehicle testing facility. I am a subjective test driver, and put it simply, I drive the car. I provide the voice of the customer to say how our tires feel when you put a new set on, when you put maybe a worn set on, and in this case today, I drive the truck.
Okay, but when you say subjective test driver, that speaks to that there's also objective tests that are done on the tires in different conditions, but you are the one giving the driver's POV of how the tires feel.
I'm giving the butt feel, the steering feel, the ears, everything that you could do with how a person perceives the tire.
Are you doing this under normal conditions? You're also doing it under extreme conditions?
Yeah, we do all sorts of conditions. I'm here 9/10 of the year, and then I actually also go up to Michigan to do snow testing for about the month of January.
So this is a pun that I just have to say. It's just like part of my brain is going to do this. But this is really for Michelin. This is where the rubber meets the road in terms of making sure their product works.
Yep, exactly. So when we say the on-vehicle test facility for North America, this is where we finally get all of our development tires and we put them on the vehicle and see what happens.
Tell me about the demonstration we're doing today.
Okay, so today we've got one of my straight trucks, and it's set up in sort of a weight configuration that you'd normally end up in if you had a lot of load in it. So I've got about 17,000 on the drive axle and about 12,000 on the steer.
So that is giving the kind of weight that it would have if it had a trailer on it.
Yep, a trailer on it, or your dump bed, or garbage truck or something like that. and we're going to be testing out wet lateral traction. So I'm going to go around and
Wet lateral traction. It sounds like drifting.
close.
Okay.
So we're testing the drive tires today, which means we kind of have a weird setup where I've got some different drive tires on the steer axle
Okay.
to make sure that we just solicit the rear tires.
So you're just trying to isolate
Right,
what the rear
just
tire
try-
behavior
Yep.
is.
And as that, just trying to isolate the rear, yeah, we're generally just slipping the rear around.
Okay.
Trying to maintain just the peak lateral traction on the tire. And then you can also check out, breakaway characteristics into a bit of a drift.
And so when you're saying peak lateral traction, if you go above that, that means you're braking traction.
Yep,
Is
you're
that right?
braking traction, you're past the peak, tire traction drops off when you go past the peak. That's why you're trying to maintain just right there at the top.
So this demonstration is about seeing where that point is, where that.
Yep.
Okay.
Where that transition is, where our peak traction is at, and then compare it to other tires to try and, see what we've got.
Okay. It sounds like this is going to be fun.
It is fun.
Okay, cool. Let's do it.
All right. So the test starts. We've got overhead sprinklers on a roughly half-mile skid pad.
Okay.
And that's putting down pretty much, we usually say 6 millimeters of water depth.
Okay. That's significant.
It is. It's a heavy downpour, only what you would see in like high puddling areas. And the track is actually designed to hold water. It's a concrete surface that has been burnished and buffed and acid etched to hold as much water on the surface as possible.
Wow.
On cars, it's used for hydroplaning testing, but when you're at higher load, higher tire pressure, in a heavy truck,
Yeah.
you end up with more of just your pure wet traction.
So this is like the worst conditions you would
Oh yeah, by far.
find in wet weather driving.
Yeah, by far. You're never really going to experience this for a sustained period of time like we're about to.
So when you come out here on a normal day of testing, are you doing hundreds of iterations, dozens of iterations?
So it can usually fit in about 6 different tires in the morning and then 6 in the afternoon. So about a dozen in one day.
Okay, so when that means you're doing the test, swapping out the tires, doing the test again, swapping
Yeah.
out the tires. Are the tires, are each set of tires you're using different?
Yeah, well, I assume they are.
Right.
When I go into testing, I try not to know what's the difference in the tires.
Right.
I've
Because
got
if you know there's a huge difference, you could have some bias
Right.
in your assessment.
Yeah. And it get to the point where, it doesn't really matter to me. I drive the car.
Sure.
That's the joke. It's my job boils down to I just drive. And I do a really good job of ignoring whatever the tires are. If you got competitor analysis where you're testing our tires against other tires.
Right.
You kind of know. You see the tire when you're setting the pressure. Oh, this is other brand. But for the most part, I don't know the difference if all the tires are made in the same mold and they change, the tread compound.
Right, right.
I'm not going to know. They all black and round is all I know when I look at them. So you're trying not to drift too much because peak traction is just before the tires really let loose.
So this is based on the knowledge that hydroplaning can happen, but you want to make sure that you can control
Yeah.
when it's happening.
Yeah, and this is where we're not really hydroplaning since we have so much weight and pressure in the tires.
Right, right.
That we're not experiencing hydroplaning. This is just as much lateral traction as the tires can give.
Oh, amazing.
Without, being lifted off the surface.
Dude, it feels so cool.
Yeah.
Dude, this feels so cool. It's like surfing.
Yeah, you just kind of slide around.
All right, so what Derek is doing on this track is called a lateral adherence test, and he's doing a demonstration of how that test works. The reason the sprinklers are going is to maintain a constant level of water all the way around his lap. And he is driving the truck at the outer limit of its ability to maintain traction. Here he comes. From inside the cab, I can tell you that you're mostly going sideways all the way around the track. It is every bit as much fun as it looks.
Okay, so these are the current model tires we're driving on.
Current model Michelin XDN2.
Okay.
Bread and butter tire. It's been around for years.
When we get onto the platform, what should I look for? Will I notice a difference?
Yeah, you'll notice a difference.
Okay.
So we're looking at overall peak traction again, and how it breaks away. And an easy way to tell is often how high are the RPMs getting? Are you hearing the motor revving up as much?
Right.
There's our initial breakaway. We're at a little
Yep.
bit lower RPMs. It's a little bit easier to step it out.
Yeah, it feels a little splashier.
Yep. Just a little bit slower, a little bit lower overall grip profile.
Still not radically different.
Not radically different. And when you're at full tread depth, brand new drive tires, in within a company, you're going to have pretty similar handling behavior. So making that small adjustment, if you're to glance at the lap timer, I think we're at about 2-3 tenths of a second slower.
Okay.
So these small improvements are really nice, and when you gain everything else that you would with a brand new tire, also being able to improve wet traction is a nice bonus on top
Right.
of everything else that you're getting.
But the tires we did the first run on, their specialty is cold weather.
Yes,
is
I
that
believe
correct?
so. Yeah.
Okay, so because I understand, you guys have helped me understand that there is no single tire that can do everything.
No.
When you build a tire for a special purpose, you want all of its other parameters to be roughly equivalent to other tires in that space.
Right.
Is
Yeah.
that
You don't want to gain a lot. Let's say gain a lot of snow, but lose all of your wet traction.
Right,
Because
right.
wet traction is generally what you're going to see more of.
So you're noticing the RPMs are a little lower for
Yeah.
this?
The RPM's a little lower. I'm not having to hold myself to the side as much.
Right.
It's just a little bit easier to break it free with the throttle and just try to maintain the perfect slip angle to hit full traction.
I'm still grooving also on the fact that you don't do this driving in the rain test if it's actually raining.
Yeah, if it's actually
because that
raining.
ruins your consistency. That makes
Yeah.
me so happy.
We got our six laps in. Let's do a little bit of fun lap, slide around a little more. And that's another thing you can look at is that hitting larger yaw angles, the front end is able to overpower the rear easier, not having to just stay at full throttle to maintain some sort of drift.
That's really neat. The difference is so specific, and I can feel there's all these subtleties that I can't quite define that I'm sure you're attuned to.
All right, Derek, we did that last test on the current bread and butter tires.
Yep, current bread and butter, industry standard XDN2.
Can I venture telling you my feeling of what that test
sure.
felt like? It felt really pretty close, but a bit splashier.
Yeah.
It wasn't a significant difference, but it was an appreciable difference.
Yeah, yep. There's a little bit of a difference there. The new X-Line Grip D has just a smaller edge, little more traction. You can really feel there's a lot of thrust when you're just at that edge of grip. There's a lot more acceleration that you can get into it than
Really?
you have on the XDN2, and that aids in a lot of stability.
And this isn't its primary design charge is water. Its primary design charge is more snow and slippery conditions, right?
Improving the
Okay.
conditions there. But you can't come out with a new product that goes backwards in some area.
Absolutely.
You have to maintain your current standing and improve on that.
This is really an intense thing from a product standpoint because you're trying to improve some things, but they all come at costs.
Yep, they do. You've got a box, and if you try and pull it to this side, usually you lose, you pull it to the snow and winter side, you're going to lose some dry and wet side. So if you can make the box bigger, that's your end goal. You want to make everything better as a global improvement.
We're in Michelin's lobby, and this is a display of all the different materials that might go in a tire. And I love raw materials because it makes it clear that even with all this technology and all the advancements that humans have made and are still making, we're still starting with the same raw materials we were 500, 1,000, 10,000 years ago. All right, Cyril, tell me exactly what you do for Michelin. What's your job?
So my job is I'm the scientific and innovation communication director for the group.
Okay.
So my background is an engineer at Michelin, and I'm kind of interfacing between the communication team and the research and development people to help understand what we are trying to explain to the people outside.
Okay, and so Michelin makes tires of all sorts, but they are also always developing tires. So talk to me about how Michelin approaches innovating new products.
So the first thing at Michelin is you need to understand that we are never satisfied.
Okay.
Okay. So that's why Michelin has been a visionary company since the start, because people were never happy with what was happening. So they were always trying to do better.
Okay.
And this is why when you look at the start of Michelin, in fact, we didn't invent the tire, but almost everything after that was an invention of Michelin in the tire industry. And then we created the major innovation in tires is really the radial tires, that was invented. But the radial tire was possible separating the function of the tread, which is, guiding the tire, and the one keeping the pressure inside with the carcass. That was only possible because we knew how to stick rubber on metal. And that was an invention that was created 10 years before. The first truck tires with metal inside, because it was very difficult to stick rubber to metal. And that was a Michelin invention also. So, and of course, after that, the radial was 1946, the first radial tire. The first radial tire in the US was 1972.
What?
So
30
you can
years?
imagine the life cycle of the tire industry is very long, because you have to rechange everything, the process to make tires.
Right.
So everything takes so much time. So 1946, the biggest invention is really the radial tire. So we put the first radial tires also on an aircraft.
Yeah.
And so it's just to show that not only we are working on truck and passenger car, but we are doing innovation in a lot of different fields, and we are present on every tire category: bike, aircraft. Even here you have a space shuttle tire.
There's a space shuttle tire?
This is a space shuttle tire.
No
here.
way.
Yeah.
They know I'm a space nut here, and they broke this out to show me this is a museum piece, but because it's not in a museum, I get to touch it. This tire flew on the space shuttle, specifically the Space Shuttle Discovery. This tire actually went to space, came down, landed, and now it is here. I can't believe. First of all, I'm kind of surprised by how small it is. I would have thought the shuttle tires were bigger. But I've seen them. I've seen them actually in museums, and I didn't take note that they were this big. This is a legend right here. It's a good sound.
So we are bringing innovation in all the domains. If you think about some major invention, people in Europe were buying, summer tires and changing in winter to what we call winter tire or snow tires. And Michelin was the first to bring really an innovation, which is a summer tire that was homologated for winter condition, which a tire that was called the Michelin Cross Climate. And since then, the market has been almost multiplied by 4 in Europe with this innovation. So, and this is what you will see here is we cascade also those technology. We have 6,000 people in R&D.
And 6,000 people in R&D.
So,
okay.
And we are spending, $700 million per year or euro per year in R&D just to keep innovating. And this is exactly what you see here is a cascading of that technology that we brought in the market in Europe with the Cross Climate that you can feel here on that X-Line grip day.
So that's the knife edge
of
6,000 people and $700 million a year spent trying to make better
again,
tires.
it's thinking about how we can bring something more into the energy tire lines in the truck industry by providing something that is also homologated for winter condition. And that's really something that is creating a sort of new category, I would say, like we created a new category in Europe with the Cross Climate, which is a summer tire homologated for winter condition, which is very different from a winter tire, and it has to work all the time. The innovation challenge is how to keep continuing to be better without having sometimes direct feedback from the consumer.
Right.
And we rely, that's why we rely a lot on data acquisition now, to be able to imagine how people are using the tires, to be able to improve. So not only on the single tire, what we do with life cycle analysis, it's a sort of theoretical calculation, but then you have to understand also in real life what's happening. And this is with all that data gathering, for example, that we understood that 20% of the tires worldwide, they never reached the end of life. They were damaged before.
I see.
They had a puncture, they had a cut, or they had a
20%?
inflation, 20%. And so how can we address that?
Right.
And that's where we started to think about airless tire.
That's what I was going to ask. Okay,
Yeah.
this
Because
is the
how
future.
you reduce the problem with puncture, sidewall cut,
Yeah.
this is airless solution. So this is what we created back in 2005. A first generation of tires with low speed application.
Okay.
High load but low speed. So this is typically what you will find on a lawnmower, big industrial lawnmower, but also skid steer, which are, you know, those little application that works on construction sites and things like that. So this has been in production and sell to our consumer. We have been working on the second generation for passenger car.
Okay.
That is called the Uptis, the Michelin Uptis, which is in test right now with DHL in Singapore, but also with La Poste in France.
Amazing.
So this is more light truck and passenger car application.
With such a different design entirely, do you find entirely different performance parameters out of this design?
Yeah, so the first thing it's you have to think about people are going back to the blank page, okay?
Right.
Because really knowing how you design tire, that how you make that, because you don't make it as a tire, you know, it's very different process. So everything has to be thought from the blank page initially. But while doing the testing, we discovered that it was providing some very interesting performance. For example, in terms of stability.
Yeah.
Because you don't have what's happening with a tire when you reach the limit, the tires start to flex under the wheel,
Sure.
okay, under the car, and start to move a little bit like that. This is more stable. Because you don't have that sort of flexing.
With the bounce of the pneumatic.
Yeah.
Okay.
So it's more stable at the limit also. And we are seeing that it could be interesting in terms of wear and longevity. But of course, the big advantage is resistance to puncture.
Yeah.
And the good thing also is, even if you cut one, you can still drive. Okay. And we try even on the passenger car tire. You can hear the noise, of course, but you can keep going. Okay. Which is not the case if you puncture your tires.
Yeah.
You have to stop very quickly. So the challenge is really how we continue to innovate for the consumer while addressing the challenge of the planet also, and, you know, reducing the impact of the tire is very important. But the interesting part is we discovered that this could be things that are going opposite direction, planet and the consumer.
Yes.
And in fact, no, they're exactly what people need today, are exactly the same performance that we are working for the planet.
Amazing.
As I said, fuel consumption or energy consumption for people who have electric vehicle, for example. They need a better autonomy. The tire can provide that. You can have a 10 to 30% improvement in the autonomy of your electric vehicle if you choose the right tire.
Well, so in a way, there's the fact that you guys make tires for everything that could have tires isn't spreading your focus. It's actually giving you a tremendous amount of institutional knowledge to bring to bear on anything you're working on.
Yeah, exactly. And that's why also we discovered that doing that on tires, we said, okay, tires is very interesting. It's a composite, in fact, because you mix things that are very different properties. They are very hard, like steel, with rubber that is very supple. And you expect all those materials to work together for a long time, a lot of cycles.
Under the worst conditions
Under the worst
imaginable.
condition. Yeah, imagine the truck tires in Thailand, for example, what we call the pineapple trucks, okay?
Yeah.
Full of pineapples, very loaded, under 35 degrees Celsius, lot of humidity, worst condition. Right. But we discovered that all that know-how we have in making polymers, understand composites, this is something we can apply to other areas outside of tires, you know, like hoses, belt.
Oh, wow.
Yeah. And so that's why Michelin is also now investing in what we call critical application, you know, like even seals in submarine application, on pipes under the sea, where you need to resist to very specific condition, very harsh condition. And we discovered that the know-how we have in composite can be applied in a lot of different applications like that. And this is also where today our R&D people are thinking. And we have many applications, even in the medical domain, for example, where we can design polymers that will degrade and be bioassimilable in the body, so that it can liberate some medication in the body at a certain rate.
Oh, wow.
Yeah. Or on a tree, for example. Instead of spreading product everywhere around the field, you put patch on the tree, and the patch will liberate the product inside the tree at the right rate, and not putting 80% of the product outside. So those are the type of application that we are currently thinking and working on.
Hello, Brad.
Hello. Nice
How are
to
you,
meet
sir?
Good morning.
Good morning. So tell me why we've got 2 trucks here on the track.
So today we're going to be running a coast down. So we got 2 different tires on 2 different trucks. Trucks are identical.
The trucks are identical, and on one truck you have the current bread and butter tires, and on the other truck you've got the brand new ones.
Correct.
Okay, so you called it a coast down test. What is the structure of the test, and what are we going to see?
So what we have did already this morning is run it for 30 minutes to warm the truck up.
Okay.
So then once you do that, then we're going to go around track 1, get to 40, and then you put it in neutral at a imaginary gate.
Okay.
And then we go coast till 0.
Oh, wow.
And we're going to see what happens.
Okay, so what does this test isolate and reveal about the tires?
Which one rolls better. So the better it rolls, the better fuel economy. So you're
Gotcha.
looking to see which one rolls better, rolls further. So we got identical trucks, identical weight.
And the tires are inflated to the exact same PSI.
Yep.
And the one with better rolling resistance is going to roll farther.
Correct.
Okay, good. I got that right.
Yeah.
These guys have the new and we have the current tires. Which truck's going to go farther?
Well, we're going to see.
All right, fair. I will wait and see.
See you. Bye-bye. Bring up their 5S.
So what we have here is we have a data logger,
Right.
and it's hooked to the tablet to show you. So same thing in a demo. So the passenger or who we demonstrate can see the distance and can see the speed. So what we're gonna do here, we're gonna get the closest to 40 as we can.
Okay.
And then we'll go to neutral. When we get around, there's a white pole on our left.
All right.
And there's an imaginary gate right there. So when we go through it, this will trigger.
Oh, amazing. Okay, so we are in the straightaway now. You're trying to get to 40, exactly 40. And then at that white pole I see up ahead, you're going to coast.
Correct.
Okay.
Yeah.
One of the things that's really impressing me about these tests is how much work it takes to get 2 vehicles to the same state of readiness. It's so critical to get that right.
So now we
Now
coast.
This is your job, just coast into a stop.
Everything got quiet.
I love it. I could get used to that.
Yeah. You said it's relaxing and just pretty day.
It's very funny to look in your side view mirror and see your opponent approaching
Makes
as
fast.
so slowly. Same conditions, same truck, same everything, just as warm, only difference is the tires. That is a really significant difference. Amazing, 150 feet. What was the speed? 39.83. Beautiful. Okay, so we're coming up to the gate.
Coming up to the gate, we're getting at 40 mile per hour.
If we stop close to the same distance we rolled before, that is a marker that our parameters are really pretty equivalent. Oh, look at that. That's a real elephant race.
Yeah, there you go.
The second test is so much cooler because they're doing the exact same thing.
Now they can see.
That's really, really neat. That's really thrilling to me that their parameters are so close. We did all of that and traveled only an extra 25 feet and they're almost exactly the same distance ahead. Amazing. Brad, that was surprisingly informational. I had no idea there would be such a massive difference.
Yep.
In a normal day of doing this kind of testing, how many iterations of that test will you do?
Certain days we can do anywhere to 60.
60.
We can do 10 3 times a day sometimes. Yeah.
Amazing.
3 different warm-ups.
Just sitting there coasting.
Coasting, relaxing, as you say.
I found that very relaxing. Dude,
Very
thank you.
relaxing in the sun.
Oh, it's just gorgeous. Okay, I know. Watching 2
trucks, coast to a stop might not be your idea of a great time, but I want to tell you why I think this is so thrilling. When you're trying to isolate some small bit of information, like in this case, the rolling resistance of a tire, how its construction contributes to its rolling resistance and how that can help the fuel economy by helping it roll farther, you've got to eliminate all the other variables. And I have a lot of experience with how difficult it is to eliminate variables. But the fact that we just ran 2 versions of that test and rolled to almost identical distances and identical distances apart is a beautiful indicator that this is a robust test that successfully has removed all the other variables except for rolling resistance, and that's why it's thrilling.